We've got a post here from Tiger83, who is running the very impressive Sunny Sky 2207 motors, big beefy motors, to go with a big beefy copter. So you got a heavy copter, but also probably pretty powerful. And corresponding to that, you're running a big battery. You say you usually run a 3S 1300. I'd be very interested to know what kind of current these motors were drawing and whether this battery was just getting smoked trying to keep up with them. But be that as it may, thankfully you're running for 5-inch props and not 6-inch. Otherwise, I think these motors would be really killing it. Anyway, be that as it may. You're running Betaflight, great. And let's just take a brief look. Oh, yeah, you've already clipped it out here. If you do give me a config dump, don't trim it, don't clip it, don't clip stuff out. You never know what I'm going to want to see. It probably doesn't matter, but since it's in this code block anyway, it doesn't take up any more space. Just give me the whole thing. So let's see what you got. Lux float, 1.8 pitch, 1.3 roll, 36 and 44 on your I terms, and 20 and 25 on your D terms. Nothing about that jumps out. Most people who are running Lux Float on Betaflight have lower P gains than this, but you're running 3S, so that probably is going to explain it. Your yaw P is 4, and your yaw I is 80. Is that 80 or 800? I can never remember. No, 44, 36, 80. I guess it must be 80 because it can't be 800 because it doesn't go higher than 256. Anyway, I'm surprised by that, and my gut is that that's too high. When I have flown, and I'm not flying your exact copter, so take it with a grain of salt, but when I have flown with eye gain on yaw that high, I've had some tendency of the copter to pull out of turns or to be reluctant to leave a turn and have had bad results. My gut is that that's higher than I think it ought to be, but anything's possible. I also see you're running, okay, you're running denom of 1. That's great because it means there'll be no aliasing in your data, and that's because you're capturing to a data flash, a Blackbox device of 1. Okay, great. So with all that out of the way, let's take a look at your actual logs. And I'm going to start here just by looking at your PID and gyro on roll and pitch. I would have always checked your gyro to start with, but with Betaflight, I think there's really not a lot of need to really think about that much unless you see signs of vibration. So let's just take a look, and mostly I'm going to start by looking at your P gains and see if they look appropriate. So let's just play the video and see how that goes. And it's going by a little bit fast, so I often like to slow it down. 50% is the lowest you can go while still hearing the motors, and I do want to hear the motors, not just because they have that awesome 2207 bullnose sound, the V8 of of multi-rotor props, but also because that lets me hear the motors, hear if there's any performance issues like oscillation, while still the traces are going by slow enough that I can kind of look for problems. Okay, so here we've got a high throttle punch, and I'm going to look for oscillations on any axis there. And the D term is a little bit in the way, so let's just get rid of the D term here. And I'm going to take that and I'm just going to set it to be the same as the next trace rather than removing it because that keeps the colors consistent. That keeps the colors consistent between them. So now the D term is out of there. And we go high throttle here. I don't see any real oscillations on pitch in the P term. Obviously the P term is always moving. That's normal. But I don't see any sort of hard oscillations that suggest that your P gains are not too high. They're not excessive. Now I think you're going to do a, what are you going to do? We've got a roll here. Let's take a look at the roll P gain or P term then. So it pushes into the move. It goes the same direction as the gyro. So it's accelerating the move. The P term then goes negative. Now it is decelerating the move. And the reason for that is that the copter has reached the targeted angular rate. It's moving as fast as it needs to go. It's moving. Now it stays negative. It finally goes positive again. That means it finally achieved, again, the targeted angular rate. It slowed down as much as it wanted to, and now it's sort of speeding up a little, but then the move ends. It goes, nope, nope, I'm going to slow down. So what I'm looking for here is I don't see any hard oscillations here in the P term as you do this move. I don't see the P term crossing the axis too many times, going back and forth. So if anything, your P gains are either just about right or they may be low. So if I were trying to tune this copter like to the ultimate degree, I might try raising your P gain, you know, 0.1 at a time, maybe 0.2 at a time at most, and only one axis at a time, roll or pitch. And as you do it, just bump it up by 0.1 or 0.2, and if you start to see or hear really oscillations or see them in Blackbox, back it back down again. But you may be able to sharpen this one up. We're not seeing any bad tendencies. It's a little hard to judge if P is too low, unless it just really gets too. If P is visibly too low, it's way too low. You should feel P being too low as the pilot before anybody who's actually watching the video would be able to tell that's what was wrong. You will feel that the copter is not responding the way as sharply as you expect it to. You'll have trouble hitting your lines. The copter will just feel like it's not responsive and not doing what you mean to tell it to do. So if you can see that P is too low, then it's way too low. Okay, so it's hard to judge here, but it's not too high, at which point you may think about raising it, but be careful. Don't take it from good to bad by doing that. All right, keep playing. By the way, did we have any bounce at the end of that move? There's a little bit of bounce back here where the gyro goes negative. It's very small, and I'll bet if we play this at full speed, we don't see it, so I'm not too worried about that. Here we go. Let's check it. Yeah, not really. Not really. That's pretty sharp ending. It looked a little soft, maybe a tiny bit soft. I don't know. So maybe that's another sign that P gain could come up a tiny bit. Just a tiny bit if you really want to feel it out. It looks pretty good where it is. Let's keep playing. So now I'm curious when you do this move, what happens with, so now we know P is not too high. It's not too high. So I'm going to stop trying to pick that apart. I'm curious what happens on yaw and roll. Let's put roll on top and yaw on the bottom. And I'm curious what happens when you do this move. Let's back this up a tiny bit. Where's the move? We've got a turn here, and I'm really curious what's happening with your yaw I term as you go through this move. So I'd also like to see RC command. Yeah, I'm going to need RC command in there. And I want RC command roll, and I want RC command yaw. Okay. Now, RC command roll and yaw. Roll and yaw move the opposite direction on the graphs. I've pointed this out before. I'll just mention it again. In other words, like left roll is positive and left yaw is negative, or vice versa. I can't remember which it is. So what that means is that when we see roll and yaw going to opposite sides of the axis, that means it's a coordinated turn. So we start the turn here. You start the turn with yaw. Here we see yaw P immediately goes negative. That's fine. We're moving into the move. Now, notice that yaw P has gone positive. Why has yaw P gone positive? Now, we can see here that you're still commanding right yaw. Yaw P is going positive because, in other words, normally if we see yaw P switch signs, we might think that you had ended the move, and yaw and P is being responsive and saying the move is over, get it over with. But here, yaw P has gone positive, but your RC command hasn't changed at all. You're still commanding the move. So why is P opposing the move when you're still commanding the move? And I think the reason is that your I term is high enough that the I term is pushing into and accelerating the move. And P is like, oh, okay, I'll go, okay, I think we need to slow down. So the I term is pushing you into the move and accelerating it. And normally we would expect to see the P term responding to RC command and the I term lagging. But here we see that the P term is not responding to RC command. The P term is actually having to counteract the I term. And I think that may be a sign of excess I. I'm a little bit prejudiced because I looked at your numbers and I sort of pre-decided that you had excess I. So take it with a grain of salt. But this is unusual that we would see the P term change signs here before you start ending the move. Normally, P is primarily responsive to the stick, but you haven't really moved the stick here. P slowly starts climbing and eventually opposes the move, even though you actually, RC command goes negative and you actually pushed further into the move. Okay? Now, as you begin to end the move, look how responsive the I term is to your stick. The I term is following your stick, and that is not what you want. You want the P term being very responsive to the stick, and the I term being slower to respond and taking a big picture perspective. So I think this is not good. It's not ideal. You probably will like it better if you reduce I to the range of maybe 40 and try leaving P where it is, but I think you're going to like it better. I don't know, maybe you won't. Here you see that the stick is now centered and the move is over. The I term very quickly reaches 0. That we don't want to see that. The I term is too responsive here and is forcing the P term to fight it. And what happens now? The P term is saying, oh, no, slow down, right? The net effect is not too bad. Notice that the gyro pretty much comes to 0 when the stick is 0, but not quite. Look, you're still drifting into the turn right here. Do you see that the gyro is negative? You're still drifting into the turn right here. Both the P term and the I term are trying to slow the move down, and it's not until right about here that you actually achieve 0 angular rate. So you meant to end the turn here, where RC command goes to 0, but because of the way you've got your tune with the I term, you continue making the move until here, which is 15.9, 15.5, 4/10 of a second later. Let's watch that and see if we can see the effect in playback. Do you see that little sort of bobble drift there at the end? That's your tune. Your excess I gain is doing that. That's my opinion. Watch it again. Right there. There's a little drift there. A little slidey, you're sliding out like your car on ice or something. That's your gyro should be hitting 0, and your P term should also be hitting 0, very close to the point where you end the move. And the I term may take a slight bit longer to hit 0, but we're not seeing that. So excess I gain on yaw is is the interesting thing that I think in this. The rest of your tune looks pretty solid. Not too much to say about that. All right, well, I hope that was educational. Thank you for your submission. Yaw is in some ways the most interesting axis to tune. I'm not sure why, but pitch and roll, you get your P gains roughly dialed in, you get your D gains so there's not too much bounce, and you get your I gain. You could almost just guess at I gain, 25, 30. Fine. But yaw seems so sensitive to I tuning and the ratio of P to I and the ratio of roll to yaw. It's almost the most interesting one to tune, and that's actually kind of backwards. I've said in the past, yaw. I used to say that yaw was not that interesting to tune, um, and most of the I guess here's what I would say. Most of the time, yaw is not that interesting to tune, but when yaw is not working right, you can really sort of get some insight into how the PID terms relate to each other. So yaw is pretty easy to tune in some sense, but when it goes wrong, it's really educational. All right. Well, anyway, hope that was helpful, and as always, happy flying.